what we're going to start looking at now for the next little bit is reflections around an axis. Okay, so we've started looking at sketching, but now we want the skill, how do I sketch something around an axis? Well, in your assessment task, one of the questions, I'm pretty sure in the start of investigation 2 or something, is like it's got half a curve drawn for you and it says it's reflected around the y-axis. Draw the other half of it, come up with an equation for it or something like that. I'm pretty sure, am I right? For those of us who looked at it, those of us who haven't looked at it, pretty sure it's in there. So I just want to start off with x squared minus 2x. It's a polynomial of what? It's a polynomial of degree 2. Beautiful. Because it's degree 2, it's parabola. What's its vertex? What do you think the vertex of this one's going to be? How do we find vertex again? Negative b over 2a. So for this one here, negative b is going to be negative 2 all over 2 lots of 1, which is just 1, isn't it? Yeah? Yes, I haven't made a mistake. Cool. Is that the vertex, just 1? No, because when I'm looking for the vertex, I want the point. The vertex lies on the line x equals 1. How do I find its y-coordinate? Sub it in. What's 1 squared minus 2? Negative 1. So its vertex is at 1, negative 1. What's its y-intercept going to be? 0. How do we know it's 0? There's no constant thing at the end. What are its x-intercepts? Now, how did you find x-intercepts with all those polynomials we just graphed? In the brackets. What do we know the brackets as? What kind of form? Factored form. Yeah? All those brackets were given to you in factored form. Quadratics and simple cubics, you're going to have to be able to factorize. How would I factorize that? Take the x out. There's no c, it's not a trinomial. I don't have to look at what is things that multiply to give this, to add this. There's no c at the end, so I'm looking for a common factor. If I take x out, it's just x minus 2, isn't it? X outside of x minus 2. Yeah? That's starting to look like all the polynomials you were sketching. Agreed? Yeah. What are its x-intercepts now? 0 and 2. Cool? Happy days? And if we were to, can you quickly yell at me those tables of values? I was expecting a number. So minus 2 squared is 4. 4 minus, isn't that 8? Yep. Yep, because minus 2 times minus 2 is positive 4. If I put negative 1 in, I get 1 plus 2, isn't it 3? Am I right, 3? Yep. When I put 0 in, I've got 0. When I put 1 in, negative 1, which we already figured that out up here. I've got, sweet. When I put 2 in, I get 0. Oh, look at that. I've now got 0. What's the next number going to be? Negative 3. Is it negative 3? It's just 3. Remember, we're symmetrical around minus 1. So when I put 4 in, what should I get? 8. No, we're not going to get 8 though. Trick jar. It's 16, isn't it? No. Oh, 4 is 8. No, my bad. I tricked myself. I tricked myself. All right, and when we look at it, and if we were to sketch it, which I've used graphing, so that comes up terrible on there, but that's what the parabola is. And you can see, well, you can't see, but that point there is the point 1 minus 1. There's the point 0, 0. There's the point, whatever that is, minus 1, 3, 2, 8, 4, 8, 3, 3. They're all those points we talked about. Why parabola? It's because the way I've zoomed it. I've manipulated my scales. How did you just work out the table of values technically? What were you doing? Well, I was doing table of values. So table of values, so remember, the table of values is what you're doing is you're literally subbing in negative 2. Negative 2 squared minus 2 times negative 2. So it's literally, like, you know, when we talked about function notation, and we talked about substituting negative 2 in here, which puts negative 2 everywhere x is. That's what we do when we're creating table of values. You're literally subbing in these values for x and evaluating. No worries. So that's it. But
Are we going to have to do that all the time?
no, no. But I'm doing it for a reason. Everyone happy with that so far? Cool, I'm going to scroll on. Now, I'm going to repeat the table of values, but what I'm going to do now is I'm going to focus on making everything negative f of x. Making it negative f of x. What do you think, what do you interpret from negative f of x? Whatever answer you get for f of x, multiply it by negative 1. Do you agree? Because this row here was f of x. But then if I want a negative f of x, notice how everything I just multiplied by negative 1. Now if I zoom out a little bit and scroll back up. Oh no, I can't too much without... Oh, anyway, I can't get the picture to be nice. Compare that to the table of values we just done. What do you imagine about that? What has it literally done? It's flipped it, hasn't it? It's literally flipped every value. What we can say is it's been reflected over the x-axis. Whenever I ask you to graph negative f of x, negative f of x is whatever function that you've just drawn, it gets flipped over the x-axis. Every y value has its sign change direction. Do you agree? Every y value here had its sign change direction. It's flipped over. What does that look like? Oh, you can't even see that really well because the picture doesn't come up good, does it? But you can see that's the parabola that we started off with previously. We said 8 became negative 8. What was this one? This was 4, wasn't it? 3. 3 became negative 3. 0 stayed 0 because I can't flip it over an axis, can I? Because it's on the axis, so we didn't change. Minus 1 became 1. It flipped over the axis. 2 didn't change because it's on the axis. Over here, this positive 3 became negative, and that became that. So you can see when we did negative, what we ended up getting was the parabola. Oh, this will test my skills. That's pretty good. Oh, that's pretty good. Thank you for coming, ladies and gentlemen. By going to, hey, here's this function, f of x, by all of a sudden chucking a negative sign out the front, just making it negative, that function, it's flipped it over the x-axis. Do you all agree with that? Literally swapped it. Cool? What have we got? Oh. What have we got here? Call it out. Polynomial of degree 3. Its leading term is, or leading coefficient, leading term? 1. So what kind of shape are we looking at? Travolta, a positive Travolta. Its x-intercept 0. How many zeros are there going to be? There's 3. When there's 3 repeated, what? We're wiggling. And what's our y-intercept going to be? Y? Because x is 0. So we know it's going to have like that wiggle. It's going to end up looking something like that, yeah? We're okay? We're getting, I'm loving this. You guys are like, bang, bang, thanks for coming. You're loving the wiggles, you're loving the bounces, you're loving Travoltas. We're all happy days. And if I did x cubed, that would be our table of values, wouldn't it? Negative 2 cubed is going to give me negative 8. Negative 1 cubed will give me negative 1. 0 cubed is 0. 1 cubed gives me positive 1. 2 cubed gives me positive 8. Is that okay so far? What's going to happen if we do negative f of x now? What's going to happen to all these? if I make it negative f of x? Yeah, their signs are all going to change. Anything that's negative is going to become positive, and anything that was positive will become negative. Oh, there's the graph of the cubic. Oh, sorry, this is negative h of x, sorry. Notice how when we got negative h of x, exactly like we said, all those signs are going to change direction. By those signs changing direction, what it's done is it's flipped over the x-axis, hasn't it? These values were initially above. This was initially 1. This was initially 8. It's now come down to be 1. It's now come down to be negative 8. It's gone from being Travolta to Travolta. Yeah? So what does that look like in Desmos? That orange line is what happens. I'm confused. I'm really not, but I'm confused. So am I. Cool. Didn't we just say negative f of x flips it over the x-axis? So everything should go over the x-axis. That looks like it's gone over the y-axis. It looks like it's done that. Do you agree? But it hasn't, because it's also done that, hasn't it? That's really weird. It's crazy. Does anyone know why it might look like that? Yeah. So y equals x cubed, remember how we could define it as an odd function? Remember we had odd functions, even functions, and neither? Because x cubed is an odd function, when we flip it over an x-axis, because it's an odd function, when it flips over the x-axis, it looks like we flipped it over the y-axis. We didn't. We flipped it over the x. It's just because it's an odd function that it makes that trick that it looks like I've done that. Is that okay? I wanted to put that in there. I was definitely not confused, but it's something to be aware of. Even though it looks like it went symmetry this way, we've actually flipped everything this way. We said positive 1 became negative 1. We said positive 8 became negative 8, and vice versa. Is that okay? Are you seeing the pattern to reflecting over the x-axis? Whatever your y values are, they now become negative. It literally goes the other way around. Oh, is that true where I'm up to now? Cool. Question time. Which one? It's those questions.
Oh.
Two, one, two. All right, so that sheet I've just handed you are the 3 questions I've got up here on the screen. So let's look at question A together. So in question A there, you can see, well, you can't really, can you guys see it on that worksheet? If I zoom in a bit. Yeah, it's dodgy. All right, don't worry, it's just dodgy. All right, so here you have been asked, here you have been given a function. Guys, shh. You've been given a function, f of x. Having a look at f of x, was it an odd degree or an even degree? If you had a look at that function. It's odd. It's got the Travolta shape to it, doesn't it? So it was this function, whatever it is, was odd. I don't care what it is at the moment. I just know that it was odd because it's got that Travolta shape. I want you to graph negative f of x. When I ask you to graph negative f of x, what I'm really asking you is, can you flip it over the x-axis? So if we look at this point at negative 2, what was at x equals -2, what's that y coordinate? It's 2. Can you kind of like when you look really close on your page, you can see it's 2. So instead of, that now needs to come down to -2. So that point is going to be now at -2. It's going to cross the axis still in the exact same spot, isn't it? That's not going to change. But this point here, this arm that's now down, where is this arm down going to be? The arm is going to start up here because I've got to literally reflect it over. So instead of, would you say this is like that positive Travolta? By making negative f of x, it's going to become the negative Travolta. So it's going to start up here and down here, start in quadrant 3, end in quadrant 4. So that's going to come down. Our y-axis is also going to go from +2 to -2. Our 0.18 is now going to come down to -8. And all we've got to try and do now is just match that curve. So it dipped, it's going to do that. So I'm just going to try and match the curve as best I can. And that is the curve y equals -f of x. Do you agree that what I've drawn matches the shape that was already on the screen, but it's now just gone over the x-axis? Is that all right? It hasn't gone because see this nature here? That's down here. When it looks like it's done that, when I'm meant to have flipped it this way, when I'm meant to flip it over the x-axis, and it looks like it went over the y-axis instead, that meant we had an odd function. That function we were graphing, there was something extra special about it. It was odd.
So why didn't you flip it on the y-axis?
Big pun?
Why didn't you flip it on the y-axis?
Because the question said to flip it on the x-axis.
Oh, okay.
Because when it says sketch negative f of x, that says flip over x, reflect over the x-axis. Negative f of x is flip over an x-axis.
How would you know when you flip on the y?
What do you think? How about we just leave it and come to it in a second? But in the back of your mind, think about it. Remember the odd function? Does this look similar to an odd function? When we put negative x in, we got negative f of x. And when we did something with odd, what made an even function even? When you substitute negative x, you got the same thing, didn't you?
So the y equals x and then bracket negative x?
That would be reflecting over the y-axis.
Okay.
Right, our exponential curve, which is the next one on your page. Again, that same idea. We're going to get all our y values that sit above the x-axis. They're all going to drop down below the x-axis. Everything that's above comes down. So instead of from left to right going all the way up in the first quadrant, from left to right it's going to come all the way and then drop down in the fourth quadrant. I'm literally just getting this and going roop. Is that okay? Sound effects. Does the sound effects make it help? Like no. So that's exponential. Not just yet. That's 2 to the power of x. So that, if I was to sketch it, would look something like that. Literally over. And this point here is now the point 2, -4. 0, -1. They're just flipping over. Is that okay? And that final curve that I've got there, what degree is that final curve you've got on your sheet, do you think? You think it's a degree? You think it's degree 5? Degree 5 or 4? It's definitely got to be an even degree because we've got both arms up. It's got both arms up. The only reason I know for sure this is going to be degree 4, you ready for this? It turns through, I don't know exactly.
It goes on the x-axis 4 times?
Does it bounce off an axis anywhere? No. So it turns 1, 2, 3 times. So because it turns 3 times,
Why was
it's degreeful.
216?
Big pardon?
Why was on the sheet 216?
216, because what we're going to do, that point 216 is now going to become the point 2, negative 16. This point here, because we're reflecting over the x-axis, reflects down here. So literally everything is just swapping sides on the x-axis. So that's going to stay, that's going to stay, that's going to stay. The point -1, -2 becomes the point -1, 2, and the point 216 becomes the point 2, negative 16, which is down here somewhere. And the whole curve, it just does the opposite. It comes up, it goes above that, it comes down to that, it kind of wiggles this way. Right? See how I've literally tried to, whatever is happening in this section, flip it above. This section was like that, so it's, you know, like that, like that. And then because the arms were up, the arms now come down, and some points for scale to make sure that I know what's going on too.
Ever have to find an equation for that?
You potentially could. This one's, you could be asked to find a equation because see how it bounces off 0? So an equation for this, we know it passes through, where does it pass through? We know it passes through 1 and -2. So I know it's going to be something like x plus 2. I know it's going to have x minus 1. I know it's those ones because it passes through positive 1, it's got to be x minus 1. Because it passes through -2, it's got to be x plus 2. I know it's an even power, so, and I know it's bouncing at 0, isn't it? So it could be x squared. That would make it bounce at 0. But any even power would make it bounce at 0. So it could also be x to the power of 6. Because x to the power of 6 would mean an even number of zeros. So it's got to bounce at 0.
And they would both equal the...
They both look very similar. Yeah. Yeah, oh, that's off the screen. But so to come up with an equation, if I asked you to come up with an equation for this, because the question would be come up with an equation, not the equation, it would definitely have to have those two, and that with an even power. And that would be an equation that could match that. Actually, no, you could come up with the equation. Because you've got 2 and 16. You know when you put 2 in, you should get 16. But if I didn't give you that 0.2 and 16 in the other one, then yeah. Good question. Oh, I've done. So everyone okay with that? Yes, no, maybe. Odd. So negative f of x just flipped everything over the x-axis. Cool. We're going to go across the page and back to the top. Oh, what am I going to do? I need to fix this up. I'm going to delete some stuff. We're going to go to the part where it says reflection around the y-axis. Oh, I'm sweating. That's now going to end up in the YouTube. And that's going to end up in YouTube. It's going to be one of those repeating processes like, was that an echo? So I'm just going to go to this page here. If the negative out the front was reflection over the x-axis, when we ask you to sketch f of negative x, that's reflecting it over the y-axis, right? Remembering that an even function, when I put negative x in, it gave me the same result out because it was perfectly symmetrical. What we are doing when we're putting negative x in, instead of our y values changing their signs, our x values are changing their signs. And that's why a parabola, when it's symmetrical around the x-axis, if I say we do y equals x squared, what's 3 squared? It's 9. If I change the sign of x, if I say, well, what was negative 3 squared? It also gave me 9. It was already perfectly symmetrical. If I have a graph that's not symmetrical, obviously those points are then going to shift differently. Right, so We said that the function was an even function. We also said that the functions were symmetrical around the y-axis. However, not all functions are even, so that we need to take care when sketching. Consider that, and what I'm going to go through here, consider that first curve. So remember that first curve we looked at, that first parabola? We come back to this one where it's got the dodgy, where it was 2, 8, 1, 3, 0, 0. This function is not even, is it? Why is this function not an even function? It passes through origin. That's okay. It can do that. Where is the axis of symmetry for this parabola?
Because if you flip it,
No, we're not talking.
it's mirrored, but it's also symmetrical across the.
This is the y-axis here.
Yeah.
Is it symmetrical across the y-axis? Because it's not symmetrical across the y-axis, it's not an even function. Okay? The axis of symmetry for this parabola, it's been shifted to the right, hasn't it? What caused a shift to the right again? Remember x squared minus 2x? Yeah. What happened when we factorized that again? When we factorized it, what did we get? X outside of x minus 2. Notice how all of a sudden we're doing something to an x. We're getting x minus 2 before we then multiply or do anything to it. That's the thing that's making it move sideways. Every single function, if we want to move sideways, we need to manipulate x before we apply it to the rest of the maths. By making it x minus 2, we're making it do that before we apply it to the squared part, which has made that shift to the right. Yep, cool. So if I was to then reflect this over the y-axis, this point negative 2, 8 comes over here to the point 2, 8. The 8 stays the same because I just want to flip it from this side to this side. I'm changing its x value. So I'm going to plot the point 2, 8. Do I have that further down? No, I don't. So I'm going to plot the point 2, 8. 2, 8 is going to be here. The next point across that we had was this point minus 1, 3. Well, the minus 1, I need to change its sign. The x coordinate changes to 1. So now I'm going to plot the point at 1, 3. 1, 3, it's going to be here. The next, well, 0, 0 stays because it's on the y-axis. It's not going to reflect around. The point 1, minus 1 will now become minus 1, minus 1. The point 2, 0 becomes minus 2, 0. The point 3, 3 becomes minus 3, 3. And then the point 4, 8 becomes minus 4, 8. And we get that parabola going this way. All right? Does it look like it got reflected? What does it look like it's done? It looked like it's been shifted sideways. That's because it was a parabola, a perfect parabola, because parabolas have an axis of symmetry. If I get the axis of symmetry from this side and reflect it to this side, because it's a symmetry, it's going to behave the exact same as if I slid it across. If we looked at other functions, then no. So, for fun, worksheet number 2, which ironically is going to look almost identical to worksheet number 1. But this time, what I'd like you to have a go at is sketching them or reflecting them over the y-axis. So we're not changing our y values at the moment, we're going to change our x values. Am I going okay? Too fast, too slow, just peachy? So a reflection's kind of making sense. And you can kind of see how if I put negative x into a function, it's changing the sign of the x coordinate. If I chuck the negative on the outside, it's changing the sign of the result. So it's changing the sign of that y function. Can you have a go at sketching those for me? All right, so I'm thinking the first two are pretty easy. That one's probably going to be the one that tricks you up a bit. Is that okay? Can you see how this, fat fingers. I dropped my turning point here is probably just a little bit too low because it doesn't identically match what's on the left. Yeah? But can you see how it drops down below and comes up? Here it's dropping down below, coming up. It wiggles and goes, wiggles and goes. It's literally just swapping x values and y values. Is that okay? Now, the fun one. There's a fun one. I don't know, why is there a fun one? Let's add them together. If I can reflect it one way, why not do both reflections at once? Yeah, the fun one. You can also be asked to combine. I can give you, can you sketch negative f of negative x? Of course I can. Of course we can. We're mathematicians. We push the boundaries to see what we can and can't do. All right? This is no different to what we've just done.
This looks really weird though.
It does look weird. The way that we tackle this one is you do one at a time. So what will end up happening on your curve, you may have 3 curves. The original one you started with, your first reflection, whether you reflected over the x-axis first or reflected over the y-axis first. It doesn't matter which one you're doing. Eventually you have to do both reflections. But you pick one and you do it first. And then you reflect it. So, given x squared plus 8x plus 15, sketch negative f of negative x. So that is a parabola. And I'm not going to ask you guys to do it. But can you see how there's 3 curves there? This light green one that you can barely see up the top, that's the original parabola. Can you see my dotted lines? Yeah. That's my construction lines. So is the dotted line my final answer? No. It's the construction on the way to my final answer. So that's why we call them construction lines. What reflection is the dotted line? Is it negative f of x or f of negative x? Negative f of x. I've reflected it over the x-axis. So you can see in my answer, I've even written it there. So I was like, no. Okay, so but you can see the first step I did was I reflected it first over the x-axis. Once I knew what it looked like, once I reflected it over, I then reflected it over this way. If you ever have to do both reflections, don't try to go from there to there, because you will make a mistake. It is. No. It doesn't matter if you reflect it this way, then you reflect that way. You're still going to get the same answer. It doesn't matter which reflection you start with, but you must only do one reflection at a time. The second you try to do multiple things at once, things go haywire. You look at your graph and you're like, what happened there?